Okay, so we're doing some extra practice for recursive and explicit in arithmetic and geometric sequences. So when we look down our tables, our only options are to either add or subtract or multiply. We will not divide. Remember, if we see that we are dividing, we have to change it to multiplication by, instead of saying like divided by 2, we say times 1/2. It's our tricky trickster way of dividing, but not really. So let's look at our first example here on this side. So we got 1, then we got 5, then we got 9, then we got 13, then we got 17. Well, let's see if 1 plus 4 works. So 1 plus 4 gives us 5. 5 plus 4 does give us 9. So that works down our table. So we're adding. This is a arithmetic. So first thing I'm going to do is always bring that first number over. So this case is a 1. Then to get from 1 to 5, I did 1 plus 4. Then to get from 1 to 9, I did 1 plus 4 plus 4. And then to get to 13, I did 1 plus 4 plus 4 plus 4. And I'm going to zoom in a little bit here. And then to get to 17, I did 1 plus 4 plus 4 plus 4 plus 4. Now I need to simplify this. In order to simplify this, right, I want to condense how many times I'm adding this 4 into something a little bit more manageable. So I only use the 1 once, so I can do that. And then I have plus 4. Now if I added 4 times, that means I did 1 plus 4 times 4. Okay? So I added in here, so that means I will multiply in my simplifying. It's just a regular number, not an exponent. Exponents are only used when in here you are multiplying. That's the only time you use your exponents. So then we have 1 plus 4 times 3, because we added 4 3 times. Then we have 1 plus 4 times 2, because we added 4 twice. Then we have 1 plus 4 times 1, because we added 4 once. And then we have 1 plus 4 times 0, because we didn't add any 4s. Okay? Now I need to write the recursive equation for this guy. So the recursive always starts with f of n equals f of n minus 1. And then what math did we do down our table? Well, we added 4. So I'm going to put my plus 4 here. Okay? After the f of n minus 1 is always that common difference or common ratio. Then, semicolon, how does our table start? Well, in this case, our table starts with a 0 and a 1. So I'm going to do f of 0 equals 1. Sometimes it will not start with a 0, just so you guys know. Now I'm going to write my explicit equation. So it always starts with f of n equals. But when I write my explicit, it's best to look at this simplified column. And the first thing you want to notice is what stays the same throughout my simplified. Well, in this case, all rows of my simplified have 1 plus 4. But those parentheses numbers in the back keep changing. All these guys right here, these change. And since they keep changing, they will be our variable because it always is different. All right. Now, we got to figure out, is this arithmetic or is this geometric? Well, this is an arithmetic sequence because it's adding. And we use a common difference for arithmetic, and our common difference in this case is a plus 4. Now let's look at the other side of this page. So now we go from 1 to 5, and then 5 to 25, and then 25 to 125, and then 125 to 625. So those first two rows here kind of start the same, but then they get way different, right? So I'm definitely not adding by 4 anymore. So let's see, and I'm not subtracting because my numbers aren't getting bigger. And to get from 1 to 5, add 4, well, I can't do 5 plus 4 to get 25. So I got to do some multiplying. That's my only option that's left. So if I'm looking at this, 1 to 5, let's do some different colors here. Well, I would do times 5, right? So let's bring this number over. We have 1, then we have 1 times 5, and then if I multiply by 5 again, that gives me 25. So now I've done 1 times 5 times 5. And then that works to get to 125. 1 times 5 times 5 times 5. That works to get to 625. So now I have 1 times 5 4 times. Okay. And again, we want to simplify this. Now this time though, we are multiplying in our expanded. So when we simplify here, we're going to need an exponent. So if you multiply in your expanded, you're going to need an exponent. If you add or subtract in your expanded, you're going to do some multiplying. Okay? So let's look at this. 1 we don't multiply 1 more than once. Then we have times 5, but we multiplied by 5 in this row 4 times. So I'm going to have an exponent of 4. In this next one, I do 1 times 5 to the third because we multiplied 5 3 times. Then we do 1 times 5 to the second because we multiplied 5 twice. Then I have 1 times 5 to the first because I multiplied by 5 once. And then, so this doesn't sound so humdrum, we have 1 times 5 to the 0 because we didn't multiply by any 5s. So, looking at a recursive, always starts with f of n equals f of n minus 1. What math did we do down our table? We multiplied by 5. So that recursive don't be changing. Now again, we have to give our start value, so semicolon, f of something equals something. Well, in this case, our table started with a 0 and a 1. So we're going to have f of 0 equals 1. Okay? So see here real quick. They both started with f of n equals f of n minus 1, and they both give us a start value as well. All right, now back to our geometric here, or our multiplying. We write our explicit f of n equals, once again, we always want to look at our simplified section to help us with our explicit. What's staying the same? Well, 1 times 5 is staying the same. That's always there. But my exponent keeps changing. So this means my variable is going to be in my exponent, and that is my explicit. All right, same thing over here, except it was an arithmetic. Same thing over here as if it was an arithmetic. I'm pointing with my pencil like you guys can see, but you can't. Got to make sure to use this. All right, now we got a circle. So is this a geometric or is this an arithmetic sequence? Well, since we're multiplying, it's geometric, right? Now, is this a common difference or a common, this is supposed to be a ratio, Miss Rawolf. It's a common ratio, right? The common ratio is the number we multiply by, and our common ratio this time is times 5, okay? So you will continue to do this all throughout. And then at the end here, I want you to fill out the differences between an arithmetic sequence and a geometric sequence.